The energy of a single snowflake falling and hitting the ground provides more energy than all the energy ever received in radio astronomy. That gives you a sense of how weak these signals are and how sensitive our systems have to be to pick these up. Scientists are trying to answer some of the fundamental questions about the universe. The SKA is the telescope that's being designed to answer those specific questions. Because we're trying to detect such weak signals from almost the dawn of the universe, we need a huge collecting area, a large number of individual dishes or antennas to amplify those signals so they can be processed and turned into information and the science. The SKA, we often say, was born global. It did develop out of conversations from scientists and engineers across the planet. We have more than 600 scientists and engineers in different organizations in many countries, defining the science to be done by the telescope and then designing the hardware and software that will be the telescope. We currently have 10 countries who are formal partners contributing money to the organization, but we have scientists and engineers in 10 other countries who are also participating. The earliest discussions about the concept for the SKA occurred in the early 1990s. And now, in 2018, we're entering what we call the critical design review phase, where we end up at the end of the year with a design for the telescope. We then go out to governments and ask for the funding to construct that telescope. We hope our partner nations will provide approval for construction and the money to go with it in the latter half of 2019. Our Chinese colleagues, one of the big areas in which they're involved is the design and construction of the dishes. They have been incredibly innovative. We've learned a lot from the Meerkat dishes, which were built by colleagues in South Africa. But what China, working with Germany, has been able to do is provide a larger dish. They're 12 tons lighter, and they're a fraction of the price. This is all lessons learned, which our Chinese colleagues have, building on their vast experience with similar technologies, have taken advantage of and have provided to the SKA, so we have an affordable SKA dish, which has been absolutely key. The prototype of which is being erected in China. So all of this is in process now, but the 133 final antennas will be erected in South Africa. It's going very smoothly. We have 9 core international consortia, each one led from a different country. Of course, it does come with its daily challenges. Communications, we cover 20 time zones. A project like the SKA really does truly transcend international boundaries. So I think the progress overall has been immense. We know we can build it. There are still some technological hurdles to overcome. We need the governments to provide the money, and we'll be off. The SKA is many things. It's a science project. It's research and development, it's engineering, it's science diplomacy, pulling countries and governments together to develop an international project. But above all, it's driven by the insatiable curiosity of humans to understand our place in the universe. So I think the Chinese team has done a superb job in delivering this innovative design. And I really want to thank all of those technicians, those engineers, the support staff, the administrators. That whole team is essential to deliver a prototype dish as is being inaugurated on February the 6th.